Hi, welcome back. We're going to do review question 2.8A. And again, remember, this is in your book at the end of chapter 2. So if you're having trouble reading the worksheet or you don't have the worksheet, you just need the review question. Now it says working backwards. So it wants us to find the z-score. So that's our final answer in the 80th percentile. So we need to know what percentile means. Well, of course I'm going to draw a picture. That means that if this was like maybe a math test or scores, that this is 0, 1, 2, 3. That's our z-score. And that the area under our curve to the left is 0.80. So what that kind of means is that you did better than 80% of the other people on the test. It could also mean only 20% did better than you. That's basically what 80th percentile means. Okay, now can I find my z? Absolutely. Finding my z, I need to get this location right here. And the way I typically do this is I just use the formula. So, AP statistics. We know in the setting of this problem, if it's normally distributed, the z-scored an 80th percentile, the actual one, we don't know, so we call that x. We would predict it to be 0 if it's been standardized, and the standard deviation is 1. So here's what's interesting. Z is that x value. So ultimately, I just need the table. If the data has already been standardized, you really just look right off the table. So I'm looking for, this is the area under the curve. So see how this picture matches. So if the area under the curve, looks like this number is closest. So that gives me a z-score of 0.84. Okay, so a z-score of 0.84, and that's my z-score. Now let's do 2.8b. It says find the z-score such that 35% of all observations are greater. Okay, so that's 35%, which really tells us that 0.65 is the area under the curve to the left. So it's almost just like the last question. I'm looking for the area under the curve and 0.65 in the left. So this picture looks like my picture. And 0.65, 0.65, let's see. Okay, so that one probably looks the closest. So I get 0.3, that's 20 away, that's 17 away. So that's pretty close here. I'm gonna put 0.39. So that's my z-score, such that 35% of the observations from a standardized normal distribution are greater than that. Awesome. Okay, next question. Review question 2.9 states low birth weight. So it gives us a data set, and it says the mean is 3,668. The standard deviation is 511. So to get this number, we're just doing 3,668 plus 511. And to get this number, we do 3,668 minus 511. Okay, and then it says babies that weigh less than, so somewhere down here, 2,500. So babies that weigh less than this are considered low birth weight. So it's most babies are not. So everybody else up here is not considered a low birth weight. So they've asked what percent are low birth weight. So what they're really asking is, what is this area under the curve? They don't know it. They want us to find out. But we can find that location, correct? using our Z formula. So AP statistics, we can find the Z if we know the actual amount. Well, we know the actual amount of a low weight baby is 2,500, and we would predict a baby to be around 3,668. And we know our standard deviation is 511. So notice from this formula, we can pretty easily calculate that Z-score. So that's going to be pretty handy. And I get a negative number, which I actually was anticipating because I'm to the left of the mean. And when I divide it from 511, I get a Z-score of negative 2.286. Now, if I know my Z-score is negative 2.286, negative 2.286, negative 2.28, and I don't even go to 6. So I wiggle over here and I get 0.0113, maybe even 0.011 something else. So that's my proportion or area under the curve. Now I could have just used my calculator, right? I know, but if you use the calculator, remember you have to write out what you typed in. So normal CDF is the lower bound, the upper bound, the mu, and the standard deviation. Notice here, I know each of those. So if I go normal CDF, lower bound is a really low number. Upper bound, which is in my calculator, upper bound I know is 2,500. Mu I know is 3,668. And standard deviation is 511. So this should give me the same proportion. So let's do that. I'm going to go normal CDF. Lower bound. I'm going to leave in that really negative number. And then the upper bound is 2,500. Now I have to change this because my mean is 3,668 and my standard deviation is 511. I hit enter and I do get almost exactly the same number. So I would take either of these. If you do it by hand, it should look like this. And if you do it by hand, it would look like this. If you do it with a calculator, it looks like that. Thanks for joining us. Check out the next video.